Hi everyone. So this is lecture 7 on arrays. And our outline for today is we're going to start out talking about some array basics. And then we're going to, and those array basics, we're going to cover some just general concepts about arrays. And then we're going to talk about some specifics in arrays in Python related to these ideas of lists, tuples, and Numpy arrays. And then once we've done that, we're going to go ahead and talk about using arrays with loops and the connection between loops and arrays. So let's dive right in. So let's talk about array basics. I wrote down a little something here already so we could save us a little time. Okay, so in math we often encounter vectors and matrices. So here we have vector v with components vx, vy, vz, and we have a tensor sigma with a whole matrix worth of components. All right. And if we want to represent these in programming, we're going to use a general data type or generic data that we're going to call an array. So we will use what we're going to call arrays to represent these quantities. Okay, if previously we talked about variables, okay, and a variable I said was kind of like a bucket. So if I had an x variable, this is a bucket, and it's really some memory address. So it has memory somewhere at I don't know some address space, and this would be a hexadecimal notation or something that gives it the address. And then it's got a value that sits in there. So, like 3, and that's an integer, so that's what, 0, 0, 1, 1, right? In binary, right? And so that's really how this is stored. Well, when we come over and think about an array is a series of these buckets that are all right next to each other in memory space. So this is, 0x1df0, and this is 0x1df1, etc. Okay, working its way over. And then each of these different values each of these different buckets can hold a value. So this one might be 3, that one might be 7, 5, -2, etc. Okay, one way to think about this is this is a little bucket. Maybe this is an ice cube tray. Okay, so you can just think about an ice cube tray and how there's little things you can put in each one. Or maybe you've played like the game on Kala, you can put a pebble in each of these little areas. Okay, so we need to learn how to represent these types of array variables in Excel and Python. And Excel is quite simple. In Excel, you just have a group of cells. So in Excel, an array is just a sequential group of cells. Okay, so this might be like A1 through A5, right? So A1 through A5. So you might have a cell here, a cell here, a cell here, right? And you put values there. So it's really just a bunch of cells right next to each other. Okay, and there's really nothing special about that. It's just the way you do it. Python's a little more complicated, I think considerably so. Okay, so in Python you have different kinds of array objects, so different kinds of data types that we're going to use. So in particular, we're going to talk about 3 different kinds. So 3 different kinds of array objects. Okay, the first one is called a list. The second is called a tuple, or I think some people say tuple. I don't know, tuple seems appropriate to me, but what do I know about English? All right, and the last one we're going to talk about is a Numpy array. Okay, these two right here are intrinsic to Python. So the Python language defines these. This one is imported through the Numpy module. Okay, right? So you need to do import Numpy. We usually do import Numpy as np, right? Usually that's all on one line, right? Okay, but that's how we import it. All right. So let's go through and talk about each of these guys real quick. So what goes on in a list? What is in a list? So a list is just set aside as follows. I'll just write the syntax. So you'll write something like my list equals, and you put a square bracket. So 4, 7, 5. You need commas, okay, and you need the square bracket. So this is square, and you need commas, right? And a list really is just a list of things, right? It's just a bunch of things that you need. So this is now an array variable. My list, it holds all of these. It's a single thing. So think it's a single thing like an ice cube tray, but it holds these 3 different things, right? We'll talk about how to access each of these 3 in just a second, right? That's the basic thing. And what are they good for? Well, lists are really good for storing lists of variables. Okay, that's what they're good for, unsurprisingly. Okay, the second thing is tuple. Okay, a tuple is made as follows. So I'm going to call this my tuple. Okay, and now you use parentheses. So let's do 4, 7, 5. So let me note here this is parentheses. Okay, and then still commas. All right, and the key idea with a tuple is that they're good for passing around arguments. Okay, good for passing into and out of functions. Okay, and the key difference between a tuple and a list is that a list you can change. Okay, so you can go in and take my list and edit it, and you can change it so that you change out this 4 for maybe a -4, right? So that one, these can change. Okay, the tuples you cannot change. Okay, they're called immutable. All right, so once you have set this as 475, that's all that it's going to do. All right, and so other than that, they're basically the same thing, and they're inherent to Python and they kind of come up everywhere. So I feel like I need to teach them to you. And if it's a little bit confusing why there are these different objects, don't worry about it too much now. Just worry about the idea of manipulating these and noting that they are different, and that this is what's going, that these you can't change and these you can. But if you do something in the function, like suppose you have define my func, okay, of x, and then you do stuff here, and then you return, suppose you return, let me do this, x squared and x cubed, and you put a comma and you can return these 2 values. What Python is doing here is it is using a tuple. It's going to use a tuple to send those back out, right? And you'll see examples of this all over the place in Python. So this is just an example to show you what's going on here. Okay, so that's the difference between a tuple and a list, and like I said, they're intrinsic to Python. So our third one here is a Numpy array. So let's talk about that last one. So Numpy array. Okay, and a Numpy array is maybe like a souped up list. So I'll say that, souped up list, okay, and for doing math. So essentially it's a list that Numpy then defines that you can do all sorts of extra things with that's really convenient to do math with, okay? And these are the things we're going to really use to represent vectors and matrices. All right? So the way that you define a Numpy array is, suppose here I have my underscore array equals, and now you're going to have to call a function, np.array. Okay, and remember when you call a function, you put it in parentheses, and now you put a list as an argument inside there. So 4, 7, 5, close. Okay, so in this case, we've defined 3 different objects. They all hold the same data, and this one, right, for a list, square bracket, comma. For a tuple, parentheses, comma, all right? And for a Numpy array, you have to call the function, right? So call function np.array, okay? With those pieces right there, okay? But inside here, maybe it'll help to have another color. Inside here, okay, this argument is a list. All right, so you give it a list and it'll create an array. What we'll see is that there are other ways. So Numpy defines a bunch of other, better go back to black, defines a bunch of other functions for creating arrays. So I'll put that here as a little comment. So Numpy defines many other functions for creating arrays. So one I'll just point out, okay, is zeros. So np.zeros, where you give it a number, say 10. And what this is going to do is this is going to create an array of 10 zeros. Okay, 10 of them. So this is really convenient, right? Because now I don't have to create a list in which I put 0, 0, 0, 0 10 times. Maybe 10's not so bad, but now imagine if I want to do 1,000, all right? Now I'd have to put 1,000 zeros. I don't want to type that out, all right? So a lot easier to just call numpy.zeros. All right? Other things that Numpy arrays are good for or I guess there's just all sorts of functions, so I guess I won't go into that here. I have another example video, so I'll just put this see example video. I think I even have 2. Okay, there's one about basics, and then there's one about array math that reviews things like matrix multiplication and dot products and things like that that you have to do between arrays. Okay, so before we jump to loops, pardon the noise there as I flip a page, before we jump to loops, I want to talk about indexing real quick. Okay, so how do I access the parts of the array? How do I do that? So let's go back and let's just look at a Numpy array for a second. So suppose I had my array equals np.array of 4, 5, 7. Okay? So if I want to look at this element here, okay, if this is my ice cube tray, it's kind of a funky ice cube tray, it's only got 3 spots. I have an address for each of these. It's inconvenient to use the actual memory address, so we use a relative address, and we call this one the 0 spot, this one the 1 spot, and this one the 2 spot. Okay? And so just like we saw with loops, the indexing starts counting with 0. So if I want to access this one here, I'm going to say my underscore array square bracket 0. Okay, and if I were to print that, if I were to put that in and print it, that would print out 4. If I do my array at 1, okay, if I print that guy, that's going to give me 5, right? So I can use that to access those, but I can also use that to assign these different values. So I could say my array bracket 2, okay, 0, 1, 2, is assigned to be -6. And now if I look at what the array looks like, okay, it looks like 4, 5, -6. Okay, here I didn't change it, 4, 5, 7. Here it's still 4, 5, 7. Okay, here I changed it. So this is the thing you can't do with a tuple. Okay, so not allowed for tuples. My face kind of covering that up a little bit. Sorry about that. Okay, so this one's not allowed for tuples, but lists, check, Numpy arrays, check. Okay, but I'm not allowed to change them for tuples. It'll freak out. Okay. So more about this in the examples. There's actually sort of simple ways of doing this and then advanced things you can do to make this even more convenient. To be able to access more of them at once, whole chunks of it, all right? What do you do if it's two-dimensional? We talk about all that in the examples, okay? So here, now it's time for the hot tip. So here we go. Let's put this one, we'll do the tip, okay? Put it in red, all right? What are we going to say here? Do not confuse calling a function, okay, that's thing 1, and accessing an array index. Okay, that's thing 2. So when I call a function, suppose I had my function, my func, okay, suppose I had 5. All right, suppose it just takes a single value. I put parentheses, okay, and there's the argument in there. That's calling a function, okay. Accessing array element, okay. That's what I want to say here is not index, I want to say element. Okay, that's what we call one of these guys, an element of the array. I use an index to access it. So the index is the number, so that's an index. Okay, which number it is, that's the element. I guess I don't want to confuse which one. That's the element to that index of 2, right? So index, element, okay, accessing an array element using an index, okay, that I'm going to do with my underscore array, in this case 2. Bracket, square bracket. All right, so don't get these confused. All right, perhaps the confusion comes, it's just easy to forget. All right, perhaps the confusion comes because of a tuple. If you access a tuple, you still use the square brackets. I just really wish that they wouldn't have used parentheses for the tuple when they define the language, but people that define the language, they're smarter than me about that, so what do they know? Okay, but if this is my array, if this is my tuple, okay, still bracket 2. If it's my list, still bracket 2. Okay, and remember, you can access them for tuples but can't change them. All right, so I think that's it for the array basics. See the examples. I think there's a lot more good stuff in the examples. Let's move on here to our last little piece and talk about loops and arrays. All right. So using loops and arrays are often, like peanut butter and jelly, right? Loops and arrays go hand in hand. Okay, so one example is filling an array with a loop. Okay, this is a super important example. As a matter of fact, I'm sure you'll have it on an exam. All right, you probably have it on multiple exams. You have to do this. So let's just look at what it could look like. So suppose I have a velocity, okay, and I'm going to call np.zeros. Remember this function I told you above? Suppose I put 3 values in it, all right? This initializes, okay, or creates my array 2, 0, 0, 0. Okay, that's great. Now I've got 3 spots for 0. Now I'm going to use a loop. For I in range of 3, colon, and then I'm going to set the velocity at index I, okay, equal to I. Let's go through this loop and see what happens, right? So at the beginning, up at the beginning up here, I have 0, 0, 0. Okay? Now I go through, and when I have I equals 0, I come through the very first time, I becomes 0. I look at the velocity of 0, so I pick out, this element right there. Okay? And I change that one to be nothing. I change it to be 0, so it becomes 0. The second time through the loop, now I'm at 1, so the range increments to 1. And now I'm on this element right there. And what happens? The velocity at 1, right? So this is velocity at 1, gets changed to be 1. Right? So that happens there. Now let me look at I equals 2. It's the last time through the loop here. Okay, now I have 0, 1. Okay, now I have this element I'm worried about, which is the index of 2. Okay, and it's changed to I equals 2. All right, and then I go one more, but range here only gave me, if you remember, this is just 0, 1, 2, because I don't do the last one, so I only have 3 values, and I'm done. Okay, so I can fill an array with a loop just like that. All right, other examples, I can use, I can fill a matrix with a nested loop. All right, so hopefully you learned about nested loops in the last one. So let's look at how I do that. Okay, so suppose I call this, sigma is equal to np.zeros. And what happens is, to get this to be 2-dimensional, you actually have to give it a tuple. So if I want to make it 3 by 3, okay, I give it a tuple. That's a tuple as an, I'm going to put this on top so I can leave my code. That's actually a tuple as an argument. Okay, to that one, that'll give me a 3 by 3. So that's going to give me something that, looks roughly like this, right? Where I have 0, 1, 2, 0, 1, 2. Those are my indices. All right, and so the way that I'm going to access this, because I haven't talked about this yet, is now I'm going to say sigma bracket one of them, say 0, 0, right? And that would give me this one right there. All right, so to have a 2-dimensional matrix now, 2-dimensional array, you give it 2 different indices, and now the elements are in 2 dimensions, like that. So if I want to fill this one up with a loop, now I can do for I in range 3, colon. Now I do a tab, right? For j in range 3, colon. Now I've got 2 different counters that I'm going to use to count both of these different indices. So usually we think about this one being the rows and this one being the columns. All right, so my rows were here, so that would be I and that would be j. Those are my columns. That's usually how we think about this, row, comma, column. All right, that's a good thing to just kind of get in your head. row, comma, column. You can think maybe a little mnemonic as an RC car. Okay, radio controlled car, row, comma, column. Right, row first, column second. Okay, for I and comma j. Now I can do sigma. Now I need another tab. Maybe I'll give myself a little more space there. Tab. Now I have sigma, and don't do parentheses. I just started writing one. Bracket I, comma j. Okay, so this one is going to be my rows. This one is going to be my columns. All right, I, comma j assigned to, in this case, for my example, I just picked I times j. All right, so let's think about how this is going to go through and step. Let me just do, so what's going to happen here? The very first thing, I is going to be 0. I is 0, the first one, and j is 0 the first time through here. And so now I'm going to make sigma 0, comma 0 assigned to 0 times 0. That'll be 0. So if I think about my array here, I had 0, 0, 0. Let's say I initialized it out here. Oh, I did already. 0, 0, 0, 0, 0, 0, 0. Okay, that's what my matrix looks like. And what I did was I accessed that guy right there first and made it 0. Well, it was already 0, so that wasn't very interesting. Okay, next time what happens? Well, now I is still 0 because I'm still working on this j loop. So now I do I equals 0, j equals 1. And now I have sigma 0, comma 1 equals I times j. It's still going to be 0. So now where am I at? So I'm kind of straddling the thing here. So look down there, right? 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, and now I'm looking at this guy right here. All right, I'm on 0, row 0, column 1, right there. All right, and that one stays 0 as well. Let's do a couple more. 0, comma j equals 2, right? Going one more time through this loop. Now I have sigma 0, comma 2, and what is it going to be, right? I'll just put this one right here, 0, 0, 0, 0, 0, 0, 0, 0. And of course, what one is it now? It's 0 because I times j is 0. So that's this piece right there, okay? And that one's 0. Let's do the next row just to see a little bit more interesting what's going on. So now what happens? So I went through this whole loop. Now I bounce up to this guy because I finished going this one and I bounce up to here and now I increments. So now I have, where'd I go? I equals 1, j equals 0. So now I equals 1. Now I'm on the second row. Okay? So what that one tells me is I have sigma 1, comma 0 is equal to, 0 again. This is pretty boring. Maybe I should have picked I plus j. We'll see though. So now I have 0, 0, 0. And what one is getting picked is this one right there. Like that guy. Okay. Let's do, switch my colors. Go back. Now I have I equals 1, j equals 1. So now I have sigma 1, comma 1. And now I actually have something 1 times 1 is 1. Alright? So when I come down here, now I've got 0, 0, 0, 0, 1, 0, 0, 0, 0. Okay? And so this one is the one I just did right there. Alright, I'll spare you more of the details. I think you get what's going on. At the end of the day, I should end up with 1, and I should end up with 2 there. Right? So my final answer, maybe you don't care about that, but maybe this will be useful. So final, we'll put ... give ourselves some closure. We're going to have 0, 0, 0. Zeros down these columns, right? Because i's and j's are multiplied. I got a 1 there. And then here I'm going to have 1 times 2. So that should be 2. Okay? And also over here, and that's in this spot right here, I'm going to have 1 times 2. So that one's going to be a 2. And then I have a 2 times 2 there, so that'll be 4. Okay? So my final answer is going to look like. Okay, so there's a couple examples filling up matrices and loops. Okay, we can also do some math. Okay, so one of the other kinds of math things we do are summation formulas. All right. So some examples of this would be a dot product. Okay, if you recall the definition of dot product, v dot w is vx wx plus vy wy plus vz wz. Okay, and a way to rewrite that with the summation formula is a sum over I, v sub I multiplied by, I'm just going to write it next to it, w sub I. Okay, so that that tells me if I here could go over x, y, z or any number, right? However many elements are in that array. All right. You can also think about doing things like matrix vector multiplication. All right. And in this case, you're going to have a dot x. Okay. I write it with a dot. It's the same thing actually as this inner product. All right. And what this, well, you can prove to yourself that this is actually a sum of aij multiplied by xj. That's what it means when I've got this matrix here with these three elements and these three guys here, and I do this times this, this times this, this times this. Okay, I'm looping over the j, okay, which is all the columns here. So that's this one multiplied by these three, okay, and then I sum them up, and then I do the next one, which is the next row. All right, so that's matrix vector multiplication. All right, and that's going to end up giving me a new vector. Okay, and also matrix multiplication. Okay, in matrix multiplication, now I have a dot b, and I write, by the way, I probably haven't said this, I put 2 lines under something for matrix, 1 line for a vector. This is something I learned. I guess it's fallen out of favor with some folks, but I really like it because it allows you to distinguish quite easily between a vector and matrix. Maybe in your math class you did vectors like this where you put an arrow over the top. Okay, that's always messy. And what do you do with a matrix? Usually in a book they'll just make it a bold, capital letter, but that's really hard to make here, as you can see from my terrible drawing. Okay, so here a times b will be a sum over j of aij multiplied by bjk. All right, so now here I've got, a like this and a b like this, and I'm going to multiply this, row, so I go over all the columns, multiplied by the 3 rows here. So notice that the columns here, go with the rows there. And then what's left over is, as I sum that up and I sum, that up and I sum that up, now as I go over each of the columns here, there's a different one for each of the columns. All right, so you can kind of prove that to yourself. And notice here, the last thing I'm going to say, just to sort of point this out in the video, is that when I have this summation formula, I'm really going to have a loop. Okay, so sums are going to be done in loops, right? Because I need to go through each one of these. So let's just take this simple example here. Let me add a new page real quick. Okay, so let me just do the dot product example. More in the other videos, okay? But if I think about this dot product example, I've got, I'm doing, let me just make it a was equal to what? The sum over, I said I of v was viwi. Okay? So I start out and I'm going to say a is equal to 0. And then I'm going to say for I in range, and let's suppose there were just 3 elements, like I had in x, y, z. All right? So notice I started out a0, and now I need to go over this range. So now I'm going to need to multiply wi and vi. So over here I'm going to have v bracket I multiplied by w bracket I. And I'm going to need that to get into a, but notice that a is this plus the next one plus the next one. So I'm going to increment a. So I'm going to say a plus equals this guy. All right, so now that's going to add that one the first time, and then the second time through, so the first time A is going to equal V0 times W0. Okay, so that's I equals 0. When I have I equals 1, A is going to equal V0 times W0 plus V1 times W1. Okay, if I just made it equal, I would erase that, and I would end up only, sorry if that my head was covering it, I would end up only with this one. So I need to do the plus equals to increment it. And then when I have I equals 2, I'm going to have A equals, now I'm going to have V0 times W0 plus V1 multiplied by W1 plus V2 times W2. Okay, so I'm going to have all three of them by doing this. All right, but notice if I start out and I don't make it 0, when I do plus equals, I might have some other stuff in here. So if this was 7 to start with, right, then I would have 7 plus that, plus that, plus that. All right, so that plus equals sort of makes it a little different. All right, so you need something like this to be able to do these summation formulas. That loop allows you to go through all the ones that you need. Okay, the plus equals allows you to sort of sum them up as you go along. All right, so there's our one example. You can see some examples of me coding this in the video. So let's just sort of step back real quick and summarize what we did. We'll kind of zoom back to our outline here. Sorry for all the zooming. Okay, so we talked about some array basics. We talked about an array as, an ice cube tray, a sequential group of cells. We talked about 3 different kinds of arrays in Python. We talked about lists and tuples. Lists you can change, okay? Tuples you cannot change, all right? And these are both intrinsic, data types to Python. Then we said Numpy arrays were more useful for doing math because we had all these extra functions and that are explored more in the examples. And then we learned really quickly about how to access the different elements using an index. And we said that there were elements of the array that we accessed by an index. Those were 2 important keywords that we learned. All right? And then finally we went through a couple examples with loops and arrays and talked about how to use them. Okay, that's all I have for you. Have a great one.